this tutorial, we're going to create this circle grid effect in Max. To start things off, I already prepared something. We have our rendering context in the form of this jit.world here. We have a jit.p window to monitor what we're doing. And I've already created this input video. So this tutorial consists of 5 parts, I'd say. The first one is drawing one single circle. The second one is then drawing multiple circles. In the third part, we're applying this circle grid to the input image. In the fourth part, we're controlling the size of the circles, of the individual circles by the brightness of the corresponding pixels in the input image. And in the fifth part of the tutorial, we're going to introduce an offset to shift every second row by a certain amount. Okay, let's start by drawing a circle. I'm going to use a jit.gl.pix code box. When you're not using Max 9, you can just use the code box within the regular jit.gl.pix object, and everything else should be the same. How do we do this? Let's start by defining our inputs. So let's call it pic in for picture in is input 1, and the output is then, for now just assign it to this one here. Then we can, oh no, that's not what I wanted. I wanted to align it, and now we can test if this, so this is already working. We have this cloudy input video here. So first part, drawing the first circle. So to draw a circle, I'm going to create UV coordinates, which are just our normalized coordinates. Let's put this out so we can see what's happening. So again, on the x-axis, we have 0 to 1 represented for the red channel, and on the y-axis, we have 0 to 1 represented on the green channel. We can also, instead of using norm in Max, use snorm, which is, I guess it stands for assigned normalized coordinates, and they are ranging from -1 to 1 on the x-axis and -1 to 1 on the y-axis. We're using the snorm coordinates for now because what we need next is the length operator to draw our circle. I mean, we can just call this one circle, take our UV coordinates, plug them in here. And then of course we also have to put this one here so we can see our circle. So what is this length operator doing? This essentially gives us the distance from the middle, so from point 0, 0 to every other point. So it's pretty dark in here because the distance is very small, and as we go outward from the middle, because we're using the signed normalized coordinates which have 0, 0 in the middle, here we're going in a negative direction, here we're going in a positive direction. And the further out from the middle, the bigger the distance and the brighter the pixels. Then we can just for now create this parameter and call it size. Let's say 0.5. And we can compare this picture, or essentially this is a fragment shader, so we are comparing each pixel of this output image to this size. So when it's bigger or smaller, let's see. Let's say when it's bigger than size, no. Yeah, okay. So each value that is bigger than the size, which is 0.5 in this case, is white, and when it's not bigger than 0.5 or the size, then the circle is black. As you can see here, the circle is kind of distorted. This this distortion caused by different dimensions, so we have to multiply our UV coordinates by the aspect ratio. So to get the aspect ratio, let's create another variable. Let's just call it ratio. This is going to be a vector because it's going to affect the x-axis and the y-axis differently, because here you can see it is only stretched in the x-axis and not in the y-axis. So to counteract this, we can take the x dimension, divide it by the y dimension, and for the y component of this vector, we can just take 1. Then here I can multiply our UV coordinates by this ratio. And let's see what happens. Yeah, so, but this is also not a perfect circle because I think this ratio is kind of off. So let's be sure to have this 16:9 ratio, so the same ratio as our input video. And now we have our perfect circle. But we don't just want to see one circle, we want for each of the pixels, or for a downsampled version of the whole thing, we want to have a single circle on screen. So for the second part, we're creating multiple circles. So I'm going to create another parameter. Let's maybe put it up here. So it's ordered by how important they are. Let's call this one num circles. And let's, I don't know, it's 5 for the moment. What we have to do now is multiply our UV coordinates by the number of circles. And only take the fractional part of that. So how can we do this? We multiply UV times num circles. And now they don't range from -1 to 1, but they're ranging from minus number of circles to plus number of circles. So we only want the fractional part, so we only want the part that is between 0 and 1. So what we're going to do is use the modulo operator, which essentially wraps the whole thing around when we're reaching values above 1. So let's do this. And now we can see, yeah, we have many beautiful quarter circles. Because the problem here is, I'm going to put out the UV coordinates here. So before we're applying this modulo operator, this is what the UV coordinates look like. And when we apply them, with this modular operator, we can create this grid where the UV coordinates get repeated by the number of circles specified here. But the problem with using this modulo 1 is that we started with these signed normalized coordinates, which range from -1 to 1. And using this gets rid of the component that is the negative component. And as you can see here, we're now only drawing part of the circle, so only the positive part of the circle. So we can't use these signed normalized coordinates. But we can do something differently down here, because up to this point, we're between 0 and 1, and we can just scale these values that range from 0 to 1 to be in the range of -1 to 1 down here. So this would be UV equals UV times 2. So now it would range from 0 to 2. And when subtracting 1, we now are in the range of -1 to 1. And now you can see we have the full circles again. We can also change the size here to be 1. Now they're bigger and barely touching. Let's set them to 0.5. So now that we're happy with the multiple circles we created, we can now apply this circle grid to our input texture. So a very naive approach would just be to, first of all, circle. I mean, here the circle is the black part, but we want the circle to be white. So I can just change this to smaller than, and now, yeah, the circles are white and the background is black. Yeah, what I wanted to say is a very naive approach would be to just take the, okay, now it's circles, multiple, to just take the circles and multiply it by the input texture, which is also a nice effect, but it's not really what we want. I can also change the number of circles here. Yeah. But as you can see, each circle contains multiple pixels of the input image. But what I want to do is each circle being a single color, so each circle representing a single pixel from the input image. And to do that, we need to downsample the input image. So essentially, we take the input image and change the dimensions so that we have the same number of pixels or the same number of squares in this case as we have circles, and then we can multiply it, and each circle will just have one singular color. So how can we downsample it? Let's see, I will comment this. Let's call it circles. Let's comment this. Let's say this is input image. So pick in equals in 1. So again, we need new UV coordinates. Let's call them pick UV. No, like this. And define them as the normalized coordinates times the number of circles. And again, doing this, you can see when I copy this down here, doing this means that we're not in the range of 0 to 1, but we're in the range of 0 to 9 in this case. So I will just take the floor component. But something is missing. We also have to divide it by the number of circles. Now we have these kind of boxy looking one singular color per square UV coordinates. Can just get rid of this and reassign it or assign it down here, because now we're sampling the input image by our UV coordinates, which means that for each of these squares we will only sample one single color from the input image. So let's do this and take this picture in and put it down here to see if it's working. Yeah, now you can see that it's working. For every square we have a single color. I can also, with the number of circles, because it's applied here, I can change the resolution down here. And now I can take the circles we have here and multiply it by this image. And now you can see that we're almost there, but the input image and the circles are not exactly overlapping. You can see here that we have two colors here, two colors here, two colors here. So it's not 100% overlapping. Because we have to apply the ratio here. And also divide by the ratio here. And now we've taken the ratio into account and the overlap should be perfect. Yeah, look at that. Now you can see that we can apply a grid of variable size to our input image. So for the fourth part, I said that I wanted to control the size of the circles by the brightness of the input image, because as you can see, every circle has the same size. I mean, I can change the size, of course. I mean, this also looks kind of cool, but every circle still has the same size. To change the sizes of the circles individually, we have to get the brightness from the input picture and then apply this value to the size that we're applying down here. So how can we do this? We have to do it up here because we need to apply it then to the circle. So let's create a variable and call it, I don't know, size factor. And this is going to be the RGB to HSL of this input picture. So we're transforming the RGB values, so red, green, and blue, to hue, saturation, and brightness. And we only want the last component that's coming out here, which is the Z component, representing the brightness of each pixel. And now I will still keep this size parameter down here because we can then again scale the whole thing. But for the individual circles, I can just take this and multiply it by this size And now you can see that depending on how bright the input pixel is, the size changes. And with this size parameter, I can just apply a scaling to the whole thing. So if I'm setting this to 1, then the maximum is going to be 1. If I'm setting this to 0.5, then the maximum is going to be 0.5. And now changing the number of circles, we can see how the size affects the individual circles. So for the last part of this tutorial, I want to introduce an offset for every second row, either in the X direction or the Y direction, because as you can see now, every circle is in the same position. So I want to shift every second row to get this kind of honeycomb looking effect. So to do this, I need to create an offset. Where would I? Okay, the offset has to be applied to. Where do I apply it? Yeah, for the input image and for the circles, because the input image also needs to be shifted to then align with the circles. So I'm going to put it up here. Let's call this section offset and create the variable called offset. So how to get the offset? I need the floor function, which means the integer part, so to say, of our normalized coordinates times the number of circles. And then we need to use modulo 2 because we only want every second one of, so every second row of them. So let's see what comes out here before I go any further. So let's reassign this down here. So yeah, as you can see, we're creating this grid, but okay, it's not really clear what's happening. I will create a parameter and call it offset amount. And here we can set the offset amount for the X and Y axis individually. And then we can multiply the output by the offset amount here to see what's happening. So offset amount is 0 for both axes. So the resulting picture is black. But if I'm changing this to 1, we can see that every second row on the x-axis is affected, and when I'm changing this to 0 and this to 1, you can see that every second row, I mean, these are rows, the other one would be columns, I guess, but every second row on the y-axis is affected. And now, I mean, the thing is, this value doesn't have to be 1. So now it's exactly shifted by 1, but we can also do anything below and above, but let's keep it at 1 for a moment. So where can I apply this offset now? First, it should be applied to our picture UV, so I can just put it into this function. Let's comment this out for a moment so we can see what's happening. So first we're applying the offset here. And yeah, because the thing is with an offset of 1, it's essentially, I think it's like using, no, it's not like using an offset of 0 because it's not wrapping around at the moment. But as you can see, something is happening. I'm shifting it, but I'm only shifting the input picture, the input video. I'm not shifting the circles at the moment. So I also have to apply this, where is it? This offset to our circle UV. So I can say UV plus equals offset. And now it's also, yeah, applied to the circles. But the problem we can see here is that we're getting every second row, but we're shifting in the wrong direction. So when I want every second row in Y direction, so to say, I want to shift it in X direction. And when I want to get every second row in the X direction, as you can see here, I want to shift it in the other direction. So how can we do it? We can just switch the normalized coordinates here. So now we're using X and Y, but if we switch this to Y and X, and also should I factor in the ratio here? Yeah, okay. So now it's doing what I want, but as you can see, we're not factoring in the ratio. So the stripes or the circle, we're not just shifting a single row of circles, but multiple. So if I'm factoring in the ratio here, this should be fixed. Okay, let's also put in YX here. Yeah, and now this is what I wanted. I can shift it in the Y direction and I can shift it in the X direction. And yeah, I mean, I can shift it as far or as much as I want. Also, I mean, these should be integers so that it really works. But what I really like is just shifting it by half a circle size. So we get this honeycomb effect. So every second row is shifted by half the size of a circle. Now we can change the number of circles. We can also go to the extreme here. So if the circles are too big, they're not circles anymore. But yeah, here I can change the number of circles. Here I can change the maximum size. And here we can shift every second row. Yeah, that's essentially what I wanted to show you. You could also adapt this and not use circles, but you could use any other shapes you may like. Circles are just the easiest to draw with this UV method, but you can also take a look in the book of shaders or on the website Shader and look into other shapes and how to draw them with this within this kind of fragment shader paradigm, and apply this to jit.gl.pix codebox, and then, for example, use triangles or squares or hexagons or something like that. That's it for this tutorial. Thanks for watching.